everyone again, I'm Juanja from Bone Studio, and today it's finally another tutorial day. So we are back with our English tutorial series. I'm sorry for those of you that requested the English tutorials of several things we've been looking at in the live streamings in Spanish. I've been unable to create English tutorials because I've been bored in work. So now we are back and we are starting a new season of English tutorials. And today we had a very special news. That is that Sebastian Vázquez announced that MantaFlow is being integrated inside Blender 2.8. So this is great news. And I thought that we could start this English tutorial series reviewing the latest build we are going to have with MantaFlow in Blender 2.79. And this is Blender 2.79.6. We can see this here. You have this exact build in graphical.org. I will put the link in the description. And I want to show you three main features that I really like from MantaFlow. Some of those features are finished, and some of them are not finished, and some of the new features will change in the new integration. But we'll talk about it later. So now let's go. We have here this scene. It's a pretty simple scene. I have a box for my domain, a collider, and a fluid. So let me save this scene just in case. And now I'm going to define my domain. And before I forget defining the rest of things, and before I configure this, I'm going to define the collider, effector, collision. We can reduce this to 0.1. We can leave it this way. And this is going to be my fluid MantaFlow, flow, liquid. And in this case, I don't want an inflow. I just want this to be my fluid. So it's going to be like a pool. Okay, we have this here, and this is okay. Now we go back to our domain, and we are going to configure some things. It has to be a liquid domain, and now I increase a pair of things. First of all, you have to enable show flip if you want to see the flip particles. Before you didn't have to do this, but now with the changes we have, you have to enable this to see the particles. Now, in liquid maximum, I used to configure 32 and 16 because this gives me more particles to review the simulation. It's not going to add detail to the simulation. It's just going to give me more particles to review the simulation with the particles. And the same for this. 3. And that's okay. And here we have the first feature that I really love from the latest features in MantaFlow. That is the Couplet cache system. What does this mean? This means that now we can simulate our fluid, just our fluid, and after we have our fluid and we have refined all those settings and the colliders, etc., we can go here and we can calculate the mesh separately. So we can simulate our fluid. After that, we can center or focus in our mesh, then bake our mesh. If we don't like our mesh result, we can free our mesh, reconfigure our mesh, and rebake the mesh without having to rebake the simulation. This is awesome. It's a really a time saver. So we are going to see that right now. And the same happens with the secondary particles, with the drop, flow, tracer, and bubble particles. But we'll talk about those particles in a bit. So let's bake the data. Another thing is that I prefer, this is a personal preference because what I've been experiencing, so I prefer to define the cache folder manually because I've been having trouble with the relative paths and the automatic cache folder created by MantaFlow by Blender. So I configure this folder manually. I go here, example cache, I have here liquid 3 because I had some past tries. So relative path, I disable relative path because I want an absolute path. Now I can save this scene and we can simulate. Let's go. Okay, And while we are simulating, we have another great feature of the latest improvements in MantaFlow. In conjunction with the Couplet cache, we have also the possibility to pause our simulation at any given moment in time. So I can pause the simulation, and you see here that we have our particles, so I can go back in time. And as you can see here, we have our particles just up to the moment where we stopped the simulation. Let's change the aspect here. We go to display. Instead of color material, we are going to configure velocity. Yeah, great. So we have here our particles. I've paused the simulation, but we can resume the simulation at any moment. So we can press resume, and then the simulation resume from the moment we left it. This is great, and this is pretty useful because if you are not sure if the liquid is behaving correctly and you don't want to wait all the simulation, you just pause the simulation, check how things are going, and then you can free the simulation and continue the simulation. Those are pretty neat adds to the simulation system because it will allow us to work faster. Now we have our full simulation. Great. Awesome. Now we can do another thing with this system. We can go here and we can increase the end frame, for example 150, and now I'm going to increase my scene 150, and automatically we can press bake data. And so great, I had to make a cut because I was distracted by one small thing about this feature. This is as follows. As I said, we can press bake data, but we can go here, configure 150, but if you try to play this, you are not going to see the simulation playing here. But if you press bake data, you will see here how the simulation continues from the very last moment you left it. So we have to simulate just 50 frames, just 50 frames, and we can pause that at any given moment in time, and we can play the whole simulation. So we can resume, and that thing that you cannot see the simulation when you change the time until you press bake data, that got me distracted, and I had to make a cut because I was saying, oh my god, it failed. No, it doesn't fail. Okay, so we have the simulation here. It's great. We have our liquid. Oh, this is the best liquid in the world. And now I can work with the mesh. So fluid mesh, and here I have the upper-res values and the radius for its particle, speed vectors. Oh, it's speed vectors. What does this mean? Well, we see it in one. And we have some values. You can play with all those values. This is not a specific tutorial. This is just to show you the new features. So we can press bake mesh and check this out. Check the speed of simulation of the mesh. This is great because once we have our simulation and we are happy with our simulation, we just can start investigating the mesh settings. We don't have to resimulate everything once and again and again and again. So here we have, let's configure this. Let's hide the flip particles and let's configure this as solid. And let me to hide this. And here we have our fluid. And we may like it or we may not like it. So we can go back here, fluid mesh, free the mesh, and I'm going to say, okay, less radius for each particle, and I want more detail. So big mesh, and check the speed. It is awesome. It is awesome. It allows us to investigate various configurations, various settings in a fast way. It's great. Now we have a more detailed mesh, a more refined mesh. Great. But I don't want to press at all. Sorry, free mesh. I just want one and speed vectors and one. as a radius. Here we have the simulation of the mesh. Okay, this mesh is a bit horrible, so let's pick at least 3 with the speed vectors. It's a bit slower because we have a lot more detail. But now that we enabled, if you see speed vectors, this means that we have motion blur. Finally, we have motion blur in MantaFlow. This is great, this is awesome. So we have this fluid, I like this fluid, and we're going to check the motion blur in MantaFlow. So I'm going to prepare a camera, lock camera to view, Shift F to move fast. And I want a frame more or less this way. I want to hide this. And I want a frame. This frame is okay, I think. Okay. Let me save. Let me put a material here. Okay, a diffuse. It doesn't matter. So CPU, because I'm recording. And I'm going to enable, I can enable motion blur, but to show you this, I'm just going to enable vector. I don't care about the aspect of this render. We can render this. Okay, let's disable this. And here we have our liquid. It's ugly, I know, but we have here vector, and we have vector information. So we can apply vector motion blur to the fluid in post-production, or if we increase this, we can put a small lamp. Yeah, point lamp will do. A bit more radius. That's okay. Okay, that's okay. We can press render. Sorry, we can enable motion blur here. And remember to configure this to 16 by 16 for the time being with the latest builds, daily builds of Blender, and use spatial splits for the motion blur. I think it works better when you have motion blur enabled. And now, yes, now we can press render and go to combined. And you can see here a bit of motion blur. We can exaggerate this motion blur. Let's tell it to use 3 frames. This is a crazy motion blur. But here we have, you have motion blur in MantaFlow. This is awesome. This is another of the features I wanted to show you. So it's great. It's really, really great. Okay. Now let's smooth this. Let's use principal BSDF with transmission at 1. Okay, much better, I think. Let's test this. Remember, I exaggerated the motion blur. Okay, we have this. I'm going to disable motion blur, and I'm going to use texture, Blender Cloud Texture Browser, just to get an HDRI from that landscape pack, for example. And yeah, okay, Blender Institute, the old Blender Institute. So use nodes, environment texture, and Blender Institute. Great. We have much better aspect here. And let's go to use a plane. Great. Awesome. So now we know we have motion blur. We know we have the couplet cache system. And we have here the same system for catching the fluid particles. So I'm going to free the mesh because I don't want the mesh for the time being. let me put this in wire. I want to show my flip particles. Okay, and I'm going to use a bit of fluid particles, of extra particles. So I'm going to enable float and drop. Here I'm going to put 20.9. Remember, 20 is the number of times a voxel is going to be sampled. So if this number is bigger, we are going to get more particles. And this is the probability, the fractional part is the probability that we are going to encounter one particle in one voxel. So if we point 9, we have a 90% probability of finding a particle. So this means more particles. So this is okay, this is okay. I'm going to put here 200 particles. Exactly the same here. I'm going to use 10.5 is okay, and maximum 200. And let's see if this doesn't crash. Remember that, and I'm going to uprise the simulation. Remember that MantaFlow is still under development, just like Blender 2.8. It's not finished. And I think I'm going to. Okay, it's not going bad. But as with the other things, at any moment in time, I can pose particles and I can see here what's happening. Okay, and we can go to we have this here and or drop particles. It's really, really great. Just to work faster, let me free this. I don't want these particles for the next thing we are going to do. And what is the next thing, the latest thing I'm going to show you? Fluid guiding. And in this feature, I'm not going to enter too deeply, just because I have to study more deeply and I need more documentation to do a proper tutorial about this. So I'm going to show you a basic thing, some basic concepts about the new fluid guiding system. Let's go for it. So we have our simulation. Sorry, here we have our simulation. And imagine that we want to do a bit like something like a swirl. Okay? What we used to do is this. We go here. Sorry, I don't want to lock the camera. Okay. We go here, we add a mesh, for example, a cylinder. We put this cylinder here, and then we go here. And this face, and this other face, and extrude. Okay. We can use this, and then we start rotating this. We animate this rotation up to the latest frame, and I want, okay, this is okay, and I want a linear interpolation, sorry, with this linear, okay, so I have a constant speed. And what we used to do was to go here, pick this object, Fluid MantaFlow, Effector, and Collision. And we configured this as a collider. And we're going to see what's the problem with this. Let's free the data. And let's bake the data. Let me save. Let's bake the data again. We can see here that this is going to last a bit more. And the problem we are going to see is that we are using a collider. So we are creating a hole in our liquid. And we don't want that hole in our liquid, because if you have a natural swirl, or you have a swirl created by some kind of vortex or whatever, you don't have a hole in the liquid. And that was a problem, because we were not able to correctly simulate these kind of things. We can pause the data, and we can see that we have our hole. Okay? Why? Because this is a collider. So we have a machine with this kind of helix here. Okay, this is great. But if what we want is a swirl, we cannot use this. So let's free the data and let's do it correctly. We go here and we use, instead of collision, we use guide. And this is the part where I need more documentation. And I need to talk with Sebas to do a proper tutorial about this. Because we have several modes. And I tried different modes, but for some things I get good results, for some things I don't get good results. I would like to have your comments in the comment section or in Twitter if you do some experimentation with this, because I really want to understand how this works. But for the time being, we are going to use the maximize guiding mode. If you let this to show, we have compare velocities from previous frame to with new velocities from current frame and keep the maximum. So it's going to keep the maximum velocity at any time. So we have source, we have guiding mode, and we go here and we have one important thing. Once we enable fluid guiding, baked data is disabled. Why? Because the fluid guiding has to be baked before the liquid simulation. So right now, this object is a guide, it's not a collider, it's not going to create a hole in our fluid. And we're going to pick this object, let's rename this to helix. And we go here and pick the helix. Helix, okay. Helix. Sorry. We are as velocity source. We have a domain, because this is another great feature we have in fluid guiding. We can use another domain with a different simulation to guide the velocities of our fluid. So, for example, in theory, we can drive liquid using smoke. For example, this is awesome. But well, we'll talk about this later. We're going to enable, instead of domain, we are going to enable Effector, and then any effector we have in our scene is going to affect the simulation. Now we have to bake the guiding. This is a fast baking. And here we can pause the guiding, but it does not make much sense. We can't see anything really. So we'll wait until this is baked. Great. And now once the guiding is simulated, we can again bake the data, but the resolution is locked up. If we want to increase the resolution, we have to disable fluid guiding, first free guiding, disable fluid guiding, then we can increase the resolution, then enable fluid guiding, then bake the guiding. So let's bake the data. And we have to check if the strength of this effector, the velocity factor, and the strength here, and the strength here, the weight, the factor, etc. is enough. So we can pause the baking, and we can see if the particles are moving, which I think they are, because this. And here you can see our fluid. Let's resume this and let's allow it to finish. So, fluid guiding is the latest of the features I wanted to show you. But I want to talk about fluid particles. Fluid particles are more or less unstable in this version. They are not working very good. But I have great news, and that news is that in the new implementation inside Blender 2.8, we are going to have an overhauled fluid particle system. I mean, an overhauled secondary particles system that is going to be different to this one, and it's going to be much better. And I know that just because Sebas told me, because I have not tried it, but I really trust in Sebas, and he has some capability of development. So here we have our final simulation. Our fluid is being driven by our guidance, we can hide our guide. And as you can see, we don't have any kind of hole. So here we have it. And we, of course, can go here. Let's disable the particles and let's enable the fluid mesh. And just to do it fast, I don't want to make a render now. And solid. And here we have our low resolution swirl. We can make a lot of things. We can, of course, for example, if we go to the guiding, we can, let's show the helix. Let's configure this to wire. We can go free the data, free the guiding, and then we go here and we say, well, I want more velocity. I want it to affect much more. I can go here and multiply by 3 and just go back here, bake the guiding. I can increase also this factor, but usually you want to increase one or the other. If you have multiple guides, you can increase each guide separately, and the factor is going to affect the full guiding. So let's bake the guide. But as I said, I want to do a specific tutorial on fluid guiding on MantaFlow, but it will be done in Blender 2.8. Right? We have Blender 2.8 and we will be able to see our simulations in Eevee. This is awesome. So here we have a guidance, and let's bake our data. This is a bit slower. Remember, just for those of you that have not seen our previous video, or if you lost some of the information about MantaFlow, remember we have here fluid diffusion, and fluid diffusion is what is going to give us density or viscosity to our fluid. But one question I receive a lot is, what is the difference between MantaFlow and the Fluid Simulator add-on? Fluid Simulator add-on is great, but Fluid Simulator add-on is just liquids, while MantaFlow, it's liquids and smoke and fire, etc. It's fluids, gaseous or liquid fluids. But one thing is right, that the viscosity settings, or the viscosity technique that uses the Fluid Simulator add-on, it's better than the MantaFlow technique, because it can allow you to have a really stiff fluid, and while MantaFlow is not going to allow you that. So bear this in mind. Both are great. MantaFlow has its strengths and Fluid Simulator has its strengths, but the viscosity settings are better in the Fluid Simulator. But in the end, in MantaFlow, you can mix smoke, you can have liquid, etc., etc. So it's, I think, and it's free and it's included in Blender 2.8. Okay, here we have, as you can see, we have much more, and we can hide the helix, and we have our swirl, and it's faster. We can go here and we are going to fluid mesh, split vectors, and let's bake the mesh. I really love the meshing stage because it's fast, it's really fast, and you can iterate really fast. Okay, and we are there. Great. Let's hide the particles and let's go here and solid. And here we have our swirl. Great, right? It's awesome. And we can go here. Let's check. Motion blur is working more or less. I don't think it's finished yet. And for the time being, the particles, the additional particles, don't have motion blur. Bear that in mind. Just the mesh. but it's going to be enabled anytime soon. Sorry, 50%, and let's render this. Let's put a solid material. Just to check if we have proper motion blur, and I think so. Yes, we could have proper motion blur if I enable motion blur. Motion blur, and just one frame. And here we have our fluid with motion blur. Of course, to notice it, we need the animation. But here it is. Let's check this, and let's try to 4 frames. I want to exaggerate it. And here is more obvious. Great, that's it. I want to name one detail about the motion blur. If I go back to the material and I use transmission, I'm going to remove this. Bear one thing in mind, I can render this. Check one thing about the fluid. If we use native motion blur, we have motion blur in the mesh, but the reflections are physically correct, because even when you have a fast moving fluid, the reflections are going to be distorted by the fluid. But this doesn't mean that the reflections should be blurred with the motion blur. That is an important thing to notice, because this is our result with motion blur enabled. And if we go to slot 2 and we go here, disable motion blur, and we render this in. I'm using just CPU because I'm recording, and even while rendering, even with CPU, the recording stutters a bit. So here is the simulation without motion blur. Pretty different, right? Great, but we can now go to compositing nodes, use node, use backdrop, and then let's add a viewer. Let's connect this, and we are going to use a vector blur. This is the image, this is the depth, and this is the vector, and we can connect this to the viewer, And as you can see, we have motion blur. We can increase this motion blur as much as we want. But one little detail is that all the reflections are being blurred too. So it's just an artistic decision, I think. If you want to be more physically correct, you have to go with the actual physically cyclist motion blur. If you want more speed and you don't care about this, you may use the post-production motion blur that is much faster, and it's still correct. You can enable curve. And that's it for today. I hope you liked this video. If you liked it, please press the like button, subscribe to our channel, and press the little bell icon so you receive notifications about new videos. We are going to start again with a lot of tutorials in English, and we are going to start with our way of working where we do the same in Spanish and English, so you can have a preview of what we are going to see in English in the Spanish streamings if you like those streamings. But usually those streamings are much larger than the English tutorials. So this is it, guys. Thank you for watching us. I hope you liked it, and we see you later in the next video with MantaFlow, Blender 2.8, or any other thing. See you guys. Bye.